uMyo, the Python side of things, and we have 4 uMyo devices, on a band, and we're going to be taking a look at it. So let's go to the drawing board. Okay, so what I have here is 4 uMyos. One of them is version 2, 2.1, and the other ones are version 3.1. So they all fit onto one of the bands that you get, and this system is super lightweight. It's super slim, so easy. Like my open muscle prototype was so annoyingly bulky. So the team at Ultimate Robotics did just an amazing job with the uMyo. So I can easily just slip it onto my arm and connect the battery terminals and pretty much be ready to go after I turn on each of them with the buttons. So before we jump too much into that, I also have the base station. So I have 2 base stations, but one of the base stations is plugged in, and I had it set behind a whole bunch of other wires, so I wasn't getting any signal. And I was curious if my code was wrong. So you really want to check to make sure that this is not obstructed by a whole bunch of interference of some sort. That was my first mistake. And I do want to go over. So if you just got a uMyo and you want to start setting it up, and let's say you're using the USB interface like I am, you're going to want to do a couple of things. So if you're using the USB interface on Windows, you want to go ahead and make sure that the uMyo is in the ports section of Device Manager, because Device Manager, if you see in other devices something that doesn't, it will look like the CP210. Sorry, it will say USB to UART bridge. It won't have a COM port. It'll be up here. If that's the case, you're gonna have to download the driver. And I do have that kind of linked. Let me pull up my files. I was not prepared for the stream. I was gonna do this stream a little bit later, and I realized I was gonna do it now because I have a little bit less time. There we go, Python tools. So I'm gonna pop that in. Hey, how's it going? Sweet, yeah, follow along. I will be sharing this code too. I put it in the Discord. I might create a temporary GitHub for this, but I'm just gonna share these files right now in Discord, because I think I'm gonna put a pull request on Ultimate Robotics repository, or maybe do my own. I'm not sure. I was speaking with 3D6, super awesome dude. I always feel bad if I annoy him too terribly much, but so for right now, I'm just leaving it in the folder. So we are going to be primarily working with the uMyo, the serial read. So let me open this up real quick. So here is the serial read program that I wrote. I didn't write this. So Ultimate Robotics wrote most of it, and then I just prepended it with 2 functions to easily find the serial port. Oh, and I'm not showing my screen. So helpful. Yeah. GitHub will be a good place to store them. NetherStar builds. And I just want to give a shout out to NetherStar builds. They're always working on super awesome stuff. I appreciate your input. It's always good to see people that are energetic about this subject. I think it's an amazing time that we live in, and the fact that this technology is pretty readily available, and we could potentially help a lot of people by building better technological devices to aid people with mobility issues, or to just create crazy new inventions. Artificial intelligence and machine learning is pretty easy to use, right? I think a lot of the difficulty comes with the multitude of steps that you might have to take and understanding. The terminology for me was a little bit difficult. But let's just get this going. Let's just make sure our base station is picking up. And if you guys are following along, if NetherStar builds, they're gonna go grab their uMyo. I think it's really important to start off doing a system in its entirety whenever you do machine learning. And that can be kind of difficult, but seeing the whole process and seeing it a closed cycle, so to speak. So if you're able to train a model, to gather the data, to train the model, and then predict the model. Once you've done all of those things, it really becomes, a lot of things become transparent. Yeah, yeah. And so it's not that difficult to do it, but there's weird little hiccups that you'll run into. But the cool thing that I use ChatGPT 4 to help me because it knows a lot about AI and it does a good job. So we have the USB stick not obstructed by something. Because earlier this morning, I was working on this for about 2 hours and this was hiding behind some electronics, and that's why I wasn't getting a signal. And so sometimes it's the easiest things. So we have our USB receiver plugged in, and we did check to make sure that we have the in device manager that Silicon Labs shows up, and it shows up with a COM port 6. So opening up the serial read here, this is the main program. I'm going to show you how it works just so you can see what the data is. We're going to have to filter this data and get a little bit more. So we're going to hit run. So what you're presented with is this screen that says here the listed devices, COM1 and COM6. And then there's another option too to auto find serial port. I wrote that just in case you had issues. I already know the serial port. It's COM1. So I'm going to select, sorry, it's COM6, which is option 1. So I'm going to select 1 and hit enter. And it said, yeah, so it started the loop and it ended the loop, right? Because it didn't detect anything. So this supposedly ran for 10,000 iterations, which is quite crazy. I don't think it did that. So I'm going to take the battery on the uMyo, and I'm just going to turn on 1. I don't want to waste the battery, even though these conserve quite a bit of battery power. And so this is how I have it set up. I just put a piece of Velcro on the lithium-ion battery, and so it stays there pretty nice. And so it's turned on. So I'm going to take the old one. This is because one of them is version 2.1, and just press the on button wherever it is. There we go. So it blinks. You can see it blinking, and it should go into blue mode. Yeah, so it's in the right mode now. So it sees stuff. So I'm going to put this on my arm. So we know that it's sending and receiving stuff. There we go. So now we can go to left screen. And I'm going to go to serial read again and run this. And we're going to select COM port 6. And now we see the data on the screen. Okay. Another star says, when I get my first paycheck, buy some more units. Yeah, definitely. So now we see that this Python program can read the data from uMyo, which is great. So it's reading it super quick. It's printing to the screen. There's lots of data, and that's just only one of the 4 turned on. So I'm going to go ahead and stop this. And I am also going to press and hold the power to turn off the uMyo. Just again, saving battery. I do have a second battery, but... So this is where I left off this morning. So I had this data. Okay, that data is fine and dandy, but what am I going to do with that data? I need to parse it. But luckily, Ultimate Robotics has already supplied us with the tools to do so. But it was a little bit Greek to me until I made this file, which is uMyo data structure. So we're going to open this up, and this is the data structure, right? So what I brought in is just the byte object from one packet. But let's go ahead and take a packet from our terminal here. Yeah, so this last one. This one's bigger. And so, right here. So that's an entire one. I'm going to copy this. And I'm just going to delete the other one. I'm going to put it in data. Okay. So now I'm going to run this. So what this is, this must be saved, okay? Perfect. So what this did is it took one packet of data, and this is what I had an issue with. I wasn't sure what did what on the Ultimate Robotics packet that was sent until I took a look at the uMyo class. Now the uMyo class pretty much tells us all we need to know about the object, about the packet, right? So this is the things inside of the packet. We got a last packet ID, a unit ID, packet type, data count, battery, version, steps, data, blah, 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 blah. So what I need to do is to parse the data, and I'm going to use their parser because I tried to read the Ultimate Robotics parser, but I'm not well versed in just plain C or C++. I'm more of a Python programmer. I wouldn't even call myself a programmer. I'm just someone who happens to know how to program, right? So what we need to do is to break to easily and legibly pull the data points that we need to put into a model, because we are going to be training this with supervised training. So we want to pull the EMG sensor data. We probably want to pull the accelerometer out of that. We're going to also get a date time stamp. So I use date time stamps because we need to have a time domain when we're doing machine learning, because that's going to let us know a lot of other information. We can calculate pretty much everything from that. And so let's just focus on only getting the bits of data that we need. So first we just printed the dir of data of uMyo. So this looks a little convoluted. I'm going to explain kind of what's going on in this just so people can understand. So this is uMyo data structure. It might be named something else. So first we're going to import binary to ASCII. I probably am not using that anymore. I'll probably throw that out. And data is just a demo packet text. So it's a byte object of one of the packets that uMyo sends to the USB receiver. So we're going to import uMyo parser because we're existing inside of the directory that Ultimate Robotics gave us. So they already have these classes and these other Python programs. So we're going to be utilizing theirs and not trying to reinvent the wheel. So let me shrink things again. So we're importing the uMyo parser, and then we run this command, uMyo parser dot uMyo parse preprocessor, and then we throw in the data. And what that does is they have the data structured in such a way that there's the class holds the variables of the packet, and they also have an array that holds the different sensors. So you can have 4 plugged in, and their parser program already does a good job of assigning it to a legible name and putting it there. So you have to use this setup if you want to tap into their great data structure that they have. So I really recommend, if you're going to be doing Python with uMyo device, you're definitely going to want to use this uMyo data structure to help you understand what the structure of the data is and how to access it. Because I'll have to be honest with you, I was looking at the code and I'm like, I just want to know the output of the sensors. How do I even find that? And I guess I just needed a month break, because when I came back and looked at it this morning, it took an hour and a half, and I'm like, oh, they did all the work. I was just trying to reinvent the wheel. So we are applying a local variable just to use this easily, and this is kind of like dummy code just to show what's inside of it. So printing the dir of uMyo prints the objects, the class of the uMyo data. So this is what we're doing. So we're gonna now just print out the stuff that we want. So I might just what's the easiest way to do this? I'm going to just make an array of the names of the uMyo variables. Sorry. So I'm going to make an array so that way I can easily call those objects back and forth. This is going to make a lot more sense once I'm done. So this text array is going to be titled var names. Var names. Okay, so we got last pack ID, and then we have unit ID, then we have packet type. Isn't this so fun, guys? I know it's kind of boring, but it has to be done. And I figured I'd stream it because this is the meat and potatoes of most of the work I do. Data count, so we got battery, um, we got version, we got steps, and we got data ID. Is that not a duplicate? No, it's not. Prev data ID. One of the things I do touch typing just to practice my typing, especially when it comes to programming. It's helpful. I think so. If you ever want to brush up on your skills, I highly encourage touch typing lessons. So those two, the QSG and 0, I'm not sure what those are. So we're just gonna do back QSG and 0Q. What? Okay, got lost here. And so this is. Wonder if can I put that inside of here? It's gonna be a sub object, I think. So we'll want that. Yaw, awesome. Pitch, if I can spell it correctly. Roll, dev yaw, dev pitch, and dev roll. Dev pitch, dev roll, update. Ooh, time. Ooh, they have a time variable. This is going to be interesting. Yaw speed. And then we want, ooh, roll speed. Okay, so they have these variables for us. Awesome. So, check this out. So we can do for I in var names, and we are going to print. I think this will work, right? Oh my goodness, this is going to be kind of fun. I forgot how to do this. We're going to print uMyo. I think I can do it this way. Print f uMyo. uMyo. And then the str I, right? I just have to put I because it's already there. So we're going to put I and then I. So I, comma, f of uMyo I. And I think that will produce it. They'll carry, right? So if we just, uMyo object is not callable. Okay. So how did I get this? This is interesting. So okay, uMyo. Oh, dot. That's right. That's right. We're gonna have to eval this. Dot I. I don't think this is gonna work. Yeah. It has no attribute I. So I need to actually do this because I need to eval this. So we're gonna put I here. And then I have to do an eval. So I'm gonna evaluate this inside of a print. This should work. Yeah. So there we go. So what we got is the packets. So we're going to print a separator here. So this is going to be begin packet dump. And I'll put some 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There we go. I have to count because I'm slow. So packet begin. So now we're looking at the data that's a little bit more legible. Let's make this a little bit more legible for you guys, so that way you can see it. So now we're taking a look at the data. So this is good. So we're getting a hold of that. So we have the last packet ID of 0 because there was no prior packet. We have the unit ID, the packet type, the data count, the battery level, which is 3.8 volts. I have that turned off. Okay. It's getting low. Version is 100. Steps 0. Data ID 35. Previous data ID 35. And this is the data array. So we got 1, 2, 3, 4, 5, 6, 7, 8. So that's also the data count. So we have 8 data points. So I wonder what this is. Are these 8 datas in a row? There are 2 sensors. Are they connected as one to get the one data value? Or how are these structured? Device specter. Okay, interesting. Device specter has some bits on here. QSG and 0Q, and then yaw pitch, all of those are turned off. I think you have to turn on or turn off the accelerometer, maybe? I'm not sure. Okay. So now we have this data, and I think they're using the data array here as the values. Whew. Okay. So let's save uMyo data structure, and these are the var names. Yeah. That's good. So I might just put find these in uMyo class. And this is just to print all of the variables in the uMyo class object. It's specified by var names. Okay. So for environment names, this is kind of fun. You have to eval this because I needed the dot to be the dot from this array, which is kind of cool. I thought that was cool. Sometimes these Python workarounds are nice. Okay. We're partway there. So I also have the last version 2 that I'm going to be using. So we're going to have this in the code. And what this is going to do is this is going to be our labeler, right? So we will want to make sure that this guy works and can transmit the data over Wi-Fi. So we're going to be using Wi-Fi, and you can see that this works. So we're going to be seeing that the Wi-Fi is going to go, these are going to be UDP packets that get sent to the computer. So we're going to set up a server to listen to the UDP packets, right? And there's only going to be one of these that we're doing, so I won't necessarily mess with the code too much to have multiple ones. And then we're going to have the data itself coming here. So this is the label, and then this is the data from the uMyo device. So I already have some code written for the other one. I'm going to turn this off for now, and then just unplug the battery on uMyo, and we're going to set up the code. So this is going to be, I am definitely going to create a GitHub repository here. Yeah, let me create a GitHub repository real quick, and I can share it with you guys, and then we can see this code updated. I'll find a home for it later, but for now, that way if you guys want to follow along. So we're going to be do a new, and this is going to be uMyo tools. uMyo tools, and just uMyo OM tools. Yeah. OM tools. OM tools. Okay, this is going to be public and a README. Please bear with me. Okay, so I'm going to open with GitHub Desktop. So that way it syncs. This is a new one. Yep, we're going to clone. Okay. And I'm going to take everything in this file, and we're going to put it inside of our documents folder for GitHub. There's 2 extra dashes, whatever. I'm going to paste, replace file and destination. Oh yeah. So now GitHub initial upload, commit to main, push to origin. Okay, so I'm putting it, I misspelled it, but go ahead and here is the link to the repository. So during this live stream, I'm going to just update the repository there, and you should be good. So okay. So now I have to open up my documents. I'm going to go into open muscles because I've already written the code for this. I don't necessarily want to reinvent the wheel. UDP server, OM capture UDP server. Okay. So we'll open that up. Sorry again for the boring time. There we go. And so this is the last packet, UDP server. Draw last. Oh, okay. So I created the server here, and what this does is it goes ahead and takes the information and plots it onto a Pygame window, which is okay. Might be overkill for us, but that's okay. Sometimes overkill is okay. uMyo tools, sweet. So I'm going to make this smaller, and if it's not legible, please forgive me. Hey, how's it going? Long time no see. Okay. We open up Python. I'm going to create new. And we're going to paste this in. Save as. And this is going to be uMyo. This is going to be training data capture. Data capture. Supervised. So it's a supervised learning technique. So we're going to be calling it data capture supervised because it's going to we're going to need to have the LASK system. So again, this is the label system, and then this is the uMyo sensors. So right now, the packet, I'm going to have to read this. How are you doing, Yo-Yo? It's been forever. I'm way behind on everything, but I finally got new sensors in from uMyo, from Ultimate Robotics. So I'm putting the machine learning to work with their sensor. I think their sensor, of course, is better than mine, but I think their sensors are going to show an amazing results. And then I can focus my time and energy in actually utilizing uMyo's sensor if it turns out to be as good as I think it is. And I think the uMyo sensor is actually fantastic so far. So I have the LASK code, which is the labeler from last time, and let me kind of have to analyze it. So it looks at the last packet. So this is also going to draw, but I think what we just need is we just need to have the UDP server set to collect this, and then we have the serial connection, the USB receiver for the sensors. So let's get those codes combined together. So the get socket IP, this is a nice one. This automatically gets our IP address. So minimum sample, maximum. Okay, yeah, this is for the last system. For the band 12, we're just gonna get, there's not gonna be any values here. So get IP address. Okay, so this is a command line program. This is what this is, the IP. Yeah, you can specify, else just get it. This is the socket server. Initiate Pygame, text surface, open muscle. And this is going to be uMyo and open muscle Lask. So these are drawing the signals. Not too worried about that. We just mostly need to look at the main loop. So the main loop is here. So for pack and get packets. Oh, yeah. So get packets is right here. This is where I have to just use my brain. Because, okay, what we want to do is we want to mimic this last band packet. So we're going to rename this to uMyo, uMyo packet. And so the ID is going to be uMyo, and we're going to call this a band 4. So that's our ID that we're assigning to it. And of course, this is the last packet, that it's just arbitrary date time object. Keep it up. I got to go work on classwork now. Okay, thanks, Nether Star Builds. I appreciate you stopping by. Okay, so the ID is for the uMyo band, and the data is it's showing the 12 5,000s. So I don't know the data structure. This is what's gonna be tricky. Okay. So when we printed this out, device specter. I think it's primarily in the data array. I'm gonna have to ask Ultimate Robotics. Um, and I am gonna go into Discord real quick and see if I can bug them. Myo, is the EMG data inside of the uMyo class data array? If so, why are there multiple values? Just trying to set up some variables. Okay, so I asked the people, the fine people at Ultimate Robotics, this question. So we can have a to do. So we have this structure in uMyo data structure listed here. We're going to have to create our own packets, and that's what these are. And these packets essentially are going to be rows, or sorry, are going to be columns inside of a Excel file. Because how machine learning works, or at least the machine learning that I'm familiar with, is that you're going to, when it comes to supervised, I'm going to supply it with a row of data, and it's going to include the sensor data and also the label data associated with that sensor data. It's all going to be in one table, and that's how I like to line it up. So each sensor for both the label and for the sensor data, they're all sensors. So I gotta specify. So the feature data. So the feature data is the, sorry, you guys see things backwards. So the feature data is the sensor data from the band, from uMyo, and the label data is from the LASK. So this is the feature data and then the label data. So what we need to do is put them on one row, each in their own column, and then we're going to use pandas and throw it into scikit-learn. So I wrote my own algorithm to match up the packets, because we're going to have to match up kind of one for one the sensor data and also the data from uMyo, because we have to use, I only know how to do machine learning in this way. I'm going to have to supply it the same information as it's going to be used to predict finger movements, with the same information while I'm training it, right? And so I want to make sure that my algorithm for figuring out how the packets are aligned is going to work, and it's not going to lose any information. So how I accomplished that with OpenMuscle is that I just took the processor ticks and the datetime objects from the microcontrollers, and from there it was able to pretty much glean as much information. And I knew that the times were in sync by a little bit. There's going to be an error rate, and it depends on the accuracy of your clock, right? So this signal from the uMyo is going to get sent to the USB receiver, processed, and loaded into Python at a certain latency. Maybe it's 1 millisecond, maybe it's 5 milliseconds, I'm not sure. The LASK system is going to have a built-in latency, but it's going to be sending over UDP packets. The latency of the LASK system is probably going to be much greater than that of the uMyo system. So what we'll need to do is run some initial tests to see what the latency is. We're going to have a running total of the latency to make sure that we can account for any adjustments that happens, and possibly lost packets. But I kind of solved a lot of this by doing a lazy thing. What I did is I'll just take all the packets and find the ones that are close enough and in a certain amount of time. So I had 100 packets per second come in. And 100 packets or 100 samples per second is enough accuracy to determine frequencies of 50 hertz and lower. Most of the stuff that I'm looking for is less than 50 hertz. So we're primarily looking at the activation of the muscles, so I'm looking for a much lower frequency. So 50 samples per second is just fine. I know the LASK system can handle 50 samples per second. The uMyo probably can handle more. I haven't tested it. So I'm going to go in, wait for Ultimate Robotics to respond back to see kind of what the data is. I'm going to be doing work in the meantime in working on the latency problem and how to make an algorithm that will match the feature data with the label data, and then we'll be back. So a lot of the work was done earlier today. This might be a boring stream, I do apologize, but this system working together kind of goes slow, and I'm trying to build things that I can use in the future. So today I built a tool that helps me see the data pretty easily. I'm using Ultimate Robotics code. I have the code in one repository so I can refine that, and everything is working as it should. Everything's talking to each other. That is a big breakthrough. So I am going to spend the time, and I'm going to spend the time to get the GitHub repository set up, to kind of do some documentation, to set some goals for myself, and to figure out what I'm going to do in what order. And yeah, I should be posting some videos soon. But yeah, thank you for joining this live stream. I'm probably going to end it. Check out Yo-Yo's work. He has a super awesome graphic user interface for a system that's just super amazing. I wish I had more time. I'm going to be taking more vacation. This week I took vacation in order to have time to do these streams and to make some videos. But I'll be putting a lot of time and energy into the uMyo code for the foreseeable future. Everything other type of video that I'm doing is just for fun, but this to me is super important because it can actually help people. So just a shout out to Ultimate Robotics, shout out to everyone that's helped Yo-Yo, Nether Star Builds, everyone encourages. And also, by the way, check out Make It Stream. He is super awesome YouTuber. You should check him out. Yeah, you should support the people that don't get much recognition because you can find those diamonds in the rough, and I think that's amazing. But I talk too much. I need to start to organize, and I'm definitely not going to live stream my organization because I don't have much organization skills. Anyways, let's see. I'm going to leave off with the same thing I always leave off. Let's see if we can make a positive difference in this world, guys. Till next time.